Hey folks, next up we're going to take a look at what's called transformations of functions or transformations of graphs of functions. The main transformations that you will see will be a horizontal shift, and that's where you take a graph and you either shift it to the right or to the left. That's a horizontal shift. A vertical shift, that's where you take a graph and you either shift it up or you shift it down. That's a vertical shift. A vertical stretch or a vertical compression, that's where you would take the graph of something, you'd stretch it or you would compress it. And then a horizontal stretch or a horizontal compression, that's where you take a graph and you'd stretch it out horizontally or compress it horizontally. You'll see this if you go on and take trigonometry. They're going to be called different things. In trigonometry you'll see a horizontal stretch or compression, that will be called period. You'll still have a vertical shift, but a vertical stretch or a vertical compression would be called amplitude. But this is college algebra we're looking at and basic functions. So I thought what we'd do is see how these transformations work in doing a graph. So a typical example. I've used the graph of f of x equals x squared. F of x equals x squared, that's a graph I would expect you to know, just like that. Use the graph of f of x equals x squared to sketch the graph of g of x equals x minus 1 quantity squared plus 3. So I'm going to do this in a couple of stages. So first off, I have use the graph of f of x equals x squared. Alright, so now remember, the graph of f of x equals x squared looks something like that. That's the graph of f of x equals x squared. Now what you will be learning is embedded in graphing g of x equals x minus 1 quantity squared plus 3. There's a horizontal shift and there's a vertical shift. So I'm going to next graph the x minus 1, that quantity squared. That's where the horizontal shift comes into play the game. When I see an x minus 1 quantity squared, what that x minus 1 means, it means I'm going to take the graph of x squared, the 1, I'm going to shift it to the right 1 unit. If it were x plus 1 quantity squared, I would take the graph of x squared and shift it to the left 1 unit. So this is the graph of x squared. This, if I take this graph and I shift it to the right 1 unit, so that means this point right here is going to end up here at the coordinates 1, 0. Now I sketch the graph. This is the graph of x minus 1 quantity squared. Graph of x squared. This is the graph of x minus 1 quantity squared. The graph of x squared shifted to the right 1 spot. Next I'll take care of the plus 3. You'll see that's called the vertical shift. Since it's a plus 3, I am now going to go up 3 units. If it were minus 3, I would go down 3 units. So that gives me, I'm going to take this and I'm going to move it up 3 units. So that means this point, which is at 1, 0, is going to go up to the point 1, 3. And let me sketch the graph. And this is the graph of x minus 1 quantity squared plus 3. And I used my knowledge of what the graph of x squared looks like to get the graph of x minus 1 quantity squared plus 3. So that's a very quick, brief look at how I can use a horizontal shift and a vertical shift to do a graph. Let's do another example. All right, in this example I'm going to do the same concept, but it's more descriptive. It's more English oriented. I'm asking, how can we use the graph of f of x equals square root x? How can we use that graph to get the graph of g of x equals 2 square root x plus 1 minus 4? And here's how I would look at it. Okay, first, I'm starting off with f of x equals square root x. If I take f of x equals square root x and I shift to the left 1 unit, that is going to give me the graph of square root x plus 1. Now if I do a vertical stretch, let me write this down, a vertical stretch by 2, so I'm stretching it by a factor of 2, that would give me the graph of 2 times square root x plus 1. Now if I look and I do my final step here and I shift vertically down 4 units, that would now give me the graph of 2 square root x plus 1 minus 4. And that's it. That's exactly how I would use the graph of square root x to get the graph of 2 square root x minus 4. Shift it to the left 1 unit. That gives me this. Stretch vertically by 2 gives me this. Vertically shift down 4 units. That gives me this. So I kind of wrote out the reasoning, the movements, what was happening, and the corresponding function that we'd end up with. That's it for that example. Thanks for watching.